Hey guys, Alan here. Welcome back to the workshop. This is part 3 of a series where I try and convert a lawnmower motor into an air compressor. Hopefully it's going to work. Anyway, the focus of this video is lubrication. So the motor is going from that orientation to that orientation, which clearly has implications for the lubrication system. So I've got to make some modifications. Let's get straight into it. Unfortunately, we're going to start this video with a big step in the wrong direction. So I thought it'd be a good idea to do a pressure test around this piece before I start putting other holes in the plate. So to make that possible, I've blocked off the spark plug hole with a thing I just knocked up, and I've made an adapter to fit a Schrader valve in there, and used the original cylinder head obviously as a backing piece. So let's see what happens. And spoiler alert, it's not good. So I have this air line set to about 10 psi, and I've only done these clamping bolts up lightly, but it should be enough for the job. You can see it leaks like a sieve around here. I'm not worried about any of the other leaks at this stage because I just haven't done these bolts up very tight. But this one here, you can see that's a real issue. So, got to pull it apart and work out how to fix that. To fix this problem, I'm going to machine a groove around the interface line between the two pieces, and to do that I'm using a round-nosed cutter. I'm not sure exactly how wide it is, it was just looked about right, and so that should put a decent sized groove around there, or trough around there, and I'll braze that and then I'll flip it over and do the other side, and hopefully that'll fix the problem. And that racket you can hear in the background, I apologise for, is building works again. So, off we go. Back to the start. So I'll get a bit of vacuum on that and see what it looks like. Right, I've decided I will go a little bit deeper, but I didn't really want to go wider, so I've swapped it out for a smaller cutter. I think this cutter will maintain this width. I'll go down, let's go down another millimetre and see what that looks like. Okay, so I'm quite happy with the groove I've got now. I think that's got a good bit of depth to it. If I manage to successfully fill that with brazing, I'm sure that this isn't going to go anywhere. So I'll take it over to the welding bench and do that now, and then come back, turn it over and machine the other side, because I don't want to take any chances with this piece coming loose, because the alignment here is obviously very important. Not that much brazing to clean off. Anyway, this the fly cutter's making easy work of it. Right, let's pull it out and have a proper look. So I'm quite pleased with the way my bit of brazing turned out. I think they'll get the job done nicely. So I'm ready to test now whether my repair leaks or it doesn't. I've made up a paper based gasket. I was using this oil jointing stuff. It'd be good for this test, but I don't think it's going to be suitable for a permanent thing. It just wouldn't stand up to the heat and pressure. But anyway, the original head gasket that I was using, I don't think that was going to work out very well. I don't know how many times they've been tightened and retightened, but anyway, this gasket shouldn't leak. So hopefully this will all go back together. I guess that's encouraging. The one area which I'm still a bit concerned about for possible leaks is here. We'll see how we get on. So I put a plug in this hole. This is one of the 4 holes that hold the valve plates onto the top, because I noticed when I did my first test it was dribbling a bit around that. So try and minimise the number of breakouts. Alright, let's get all these tightened up. Alright, £10 per square inch, let's see what happens. Okay, so I've made little gaskets under each of the nuts and put the weakest Loctite I've got as a thread sealant, and tightened it up to 140 inch pounds, and that's as tight as I want to take it. So let's see. I've upped the pressure to 20 pounds. No, sorry, I've upped the pressure to 30 pounds per square inch, and I've inspected it. All of the leaks that you can see here are actually air coming through this gasket or around the gasket, and the gasket material I've used is not pressure rated, it's just what I happen to have. But importantly, my repair here, there's no leakage going on at all around there, so I'm pretty happy about that. So I think I can press on. It does highlight though that I will have to invest in some particularly appropriate gasket paper for the final version. Okay, so now I've got confidence in my cast iron valve plate. I'm going to tear into the engine. I'm starting off with pulling the valves out. So the way these things are held in is quite different from a car. Any car I've ever seen had anything to do with anyway. So you have don't have the 2 little collets that sit down inside a keeper on the top. The keeper itself has got a slot in it, and the head of the valve, it comes up through the spring obviously, and hooks in there. I'm not sure whether I've got that in sharp focus, I'm sorry if I haven't, but anyway, so that's how that lot works. So to get them out you have to compress the spring enough that you can slide this keeper sideways and then it all falls apart. And the other thing to notice is there's an index mark on the side of this keeper, which is the opposite side to the slot. So if you work out where that mark is, then you can work out whether you should be pushing or pulling or whatever. So let's have a go, see if we can get this guy out. There is of course a special Briggs Stratton tool for compressing these, but I've seen people on the internet using just a regular old, they're called various things, trim clip remover, whatever. Anyway, I've found that if you have a little block or something like that, you You can push that down in there, and then with my third hand, this really needs to be fixed, so I'm going to try and put that in the vise, I think. Alright, so I just slipped that spring back in there just to support that little block, make it easier for me. So first thing I'm going to do is find out which way around this little colliery thing is facing. Oh, and in fact it's obligingly just fallen off anyway. Alright, well, there we go. I'm not going to look a gift horse in the mouth. So, with the valve out, just need to hook that little guy out. There we go. Not really anything particularly difficult about it. Get that up past the bottom of the valve guide. Sorry, get the end of the spring out over the top end of the tappet, I should say, or the cam follower. Right, both valves out. Okay, so for now I'm going to put this cover back on. Cover the valve, I'm not sure what you call it, valve chest here, I don't know. Anyway, just snug them up for now. Right, that's that. It's time now to do some open heart surgery. So before I open this thing up for its surgery, I of course cleaned it off as best I could. Cleanliness being next to godliness or something. Anyway, so now see if we can get this piece off, whatever it's called, half the crankcase I suppose. To keep an eye on these bolts as well to see if they're all the same length. All the same so far. Yep, all the same. Just get a tray to put them in. Alright, well, with a bit of luck, this piece now will just come off. Never had one of these apart before. It's entirely possible that I've missed something. Entirely possible. And I think there are some dowels as well, and that's perhaps where we'll focus the tapping energy. It started to move, and yeah, it looks like we're off. Okay. And I'll wire brush the end of the crankshaft here, hopefully to make it a bit easier to get things off. No, it was moving, now it's stopped. Why is that? Let's see if there's any chance of separating this to preserve the gasket. Looks like most of it's going with this piece, so let's see if we can encourage the rest of it to go with it. And at least it'll be available to me as a template. I think that was a bad. Yeah, it's just ruined the gasket. Make sure, not being familiar with these engines, I've got to make sure I'm not pulling the crankshaft through from the other side. It might be a good idea to put that other flywheely thing back on while I'm doing this, just to make sure the crankshaft isn't being pulled back through that way. I haven't cleaned this thing yet. It's a fairly dirty, disreputable looking object, but let's put the nut and washer on. You'll at least make sure the crankshaft isn't getting pulled through the other way. So some sort of pulling against the crankshaft might be the go, I think. Okay, I'm going to get a puller set up. I'll bring you back. Okay, this is extremely crude and ugly, but let's see if we'll get the job done. That seems to be working. No doubt there's an expensive Briggs Stratton tool that's intended for this. We seem to be getting there. Alright. Okay, very crude and low tech, but it seems to have done the job. Alright, well that's not a very attractive state inside, is it? Anyway, it's all going to get cleaned up. Set this piece to one side for the moment. Alright, well let's take him out of the way, take him out of the picture for the moment. Alright, what have we got here? That's the camshaft, we don't need that anymore. And the lifters or tappets, don't need them either. So to get the lubrication working correctly when the thing's in this new orientation, apparently, there's an oil drain hole under here, under the crankshaft, that has to be fixed. So I'll take the, undo the big end cap and get the crankshaft out of the way so we can get to it. So I have to bend a couple of tabs back, which are lock tabs on the thing. There's a 1/4 inch bolt. Oh, it's pretty tight. Swing the crankshaft around a bit to get it the other one a bit better. There we go. Yep. Handy little ratchet driver this, you can, it's got a 90-degree gearbox in there. I don't know how well you can see that, but when you turn the handle it rotates pretty useful. Yeah, I think that's got it. Loosen that side anyway. Right. Well, that looks pretty reasonable. Yeah, I think that's going to make it a bit easier. Right. One crankshaft out. Bearings look pretty good. Yeah. Right. Let's see if we can zoom in on that to have a proper look. The hole is there. I've got to find a way to plug that hole. Okay, I've had a close look at that hole and I can see, I was wondering how it was made. I can see it was drilled through here to come up there. So this spike was then put in to fill the drill hole. So I'm going to have a go at pushing this pin back out and see whether that allows me to get a good access to put a screw or something in this hole. So my current plan, I've made up, this is a bit of 5/16 rod. I've just made a wedge shape, so I'm going to hopefully, I'll put that there, and we'll see whether a tap with a hammer will shift it. Here we go, let's see what happens. Oh, I think that's moved it backwards. Yep, let's have a look from the other side. Oh yes, that's definitely moved it, you can see. So it should be fairly easy to extract it now. Your claw hammer perhaps. There you go. Well, getting that out was easier than I was expecting. Alright, so now let's have a look at the idea of putting a tapping and screwing or something. Okay, so this is a number 20 drill, and as you see it's smaller than the outer hole here, but a very good fit into the inner hole, the one that we actually want to block off. Perhaps you'll just be able to see there the butt end of the drill, so that's why I've marked it with the tape, so I can see it's actually sticking in a little bit. So what I'm thinking to do is make up a special screw, tap it into this outer piece and have a nose on it which will stick into that hole and block it that way. So now I know that the stub that goes into the hole has to be a number 20 drill size, and I know how long things need to be. So, simple little job on the lathe to make the screw. Okay, well that turned out to be even easier than I was expecting. Turns out the hole down there is 4.1 millimeters diameter, which is exactly the right size for tapping a number 10 32 TPI thread. So I just ran that tap right through. The outer hole here is slightly larger, but it doesn't matter, 4.2 or something instead of 4.1. So the screw is a little bit floppy in that, but it doesn't matter. It winds in, and I've cut the screw to be about, I don't think you can quite see it, don't think you'll quite see the end of it down there, but it's pulls up about a millimetre or two short of going into the bore. So you can see the screw coming out of the hole now. So I'll put thread sealant on the last quarter inch or something here, and then wind that in, Loctite, and that's what will hold this thing in place. And I'll also have thread sealant on the outside just to stop oil leaks to the outside. So that turned out to be trivially easy. Okay, so putting that screw in there was the only modification I needed to do as far as oiling is concerned within the case. I don't care about the camshaft obviously. So the way this will work now, this will be the top, so up here will be uppermost. So oil will splash around in here, land there, run down into this bearing here, this bearing journal, and it'll work its way through, and then the seal on the other side's got a groove on the inside to trap any oil that gets through, and that will come back through this weep hole back into the sump. So let's finish that. So the only other thing I have to do in here now is when the crankshaft goes back in, I'll have to make an oil slinger which will fit onto the bottom end of the onto the big end here, because obviously I've taken the oil slinger away from here. But I'll come back to that. I think I'll look at the other part of the case next. So for the other part of the crankcase, there's a few or several things to do here. So this was the oil fill hole, and it turns out that thread there is in fact just 3/4 16 I think it is. So it's easy enough to make a special thing to work with that. But I think realistically, for what I'm doing, just reusing the old plug's going to be good enough. I think it'll work okay in that position, using this as the drain plug, and I'll just have to tip it to get all the oil out. Well, it's not the end of the world. And what was the drain plug here, I think will have to become the fill plug. because I'm thinking that the correct oil level is going to be somewhere about where that is, across here somewhere. Certainly doesn't need to be any higher than that. But in this orientation I need to, again I don't care about that because it's for the camshaft. Here I need it to be so that oil splashed upwards can come down through that and stay in here. So I need to block this off and probably make this a little bit more angled back the other way, so oil can be easier for oil to find its way down in there. The side of the crankshaft runs very close proximity to this face. In fact, this is really a thrust face, I suppose you'd say. So with this blocked off, oil that comes down there will find its way in that V or chamfer there, and then through that groove find its way through. So the fact that there isn't a groove on the top there I don't think is a problem. So what I have to do is fill that in and make that angle to the top of that angle back the other way. So options. I imagine the easiest thing is the JB Weld path. I'm a bit loath to use that stuff, but in this case that might well be the best option for me. Failing that, I can, there's not an awful lot of meat there. I was idly wondering if I could drill and tap and put anchor a block of something there, but I think that's probably making more work for myself than is justified. Okay, so I've decided the best way to create a pocket here, or a little sump to help direct oil into this bearing, is to use this 90-degree countersink cutter, and that should be able to create a reasonably shaped well, little mini sump just there. So let's see how that works out. I'll do a very tentative cut to start with. Now that looks pretty good. And if I can go down a bit deeper and make it longer, see how that might work. Yeah, I reckon that'll do. Alright, so I've used the JB Weld to fill in this spot here, and I think you can see that it's turned out alright. Perhaps the lighting isn't ideal, but anyway, I think you get the idea. So I used sticky tape and various bits of shapes to get a nice clean profile there, so that's fine. So I think you can also see here a little bit of machining that I did, and after I pulled it out of the milling machine I touched it with a file so we get a nice little well and drain in, so that should work out fine. Since I have removed the oil flicker that sits on the top of the camshaft, I need to do something else to splash oil up into the bore particularly. That's the main area, but obviously all around the crankshaft as well. And the horizontal shaft Briggs Stratton motors have what they call a dipper, and so I'm trying to mimic that here. So I've got a piece of bent wire just to show the basic shape to aim for, and see if I can turn this in the correct direction. So as that turns, you can see the path that dipper thing describes, and my piece of bent wire shows that the path that I'm on there won't hit anything. So the next job is to make something that is that shape, but out of flattened metal strip basically, or some piece of metal anyway, with a foot on it, which can tolerate the being thrashed through oil all the time. I've seen some which are just fitted onto one bolt, one big end bolt, and that seems a little bit sus to me, although you can make things a bit better by having tabs that fold down around. I think I'd much rather have something that engages on both big end bolts, and then its location and orientation is not going to move. So I'll get into that and see what I can come up with. Okay, so I'm trying to make a prototype for a dipper to flick oil up to the top of the crankcase, up under the piston. And this fits onto the back of the big end bearing quite nicely, except that when it swings around it fouls here. Now this piece of the cylinder, or this piece of the crankcase, supports the camshaft followers, or the tappets. So it's completely redundant to me, and I'm going to use this cutter to mill off some of this block down here, which is where my prototype is fouling. It's just a height thing, but anyway, so I'm going to just drop this down to, I don't know, about there somewhere probably. Let's see how that goes. So for this setup, I've clamped the cylinder block to an angle plate, in fact using my valve plate as a shim, I suppose you'd say. Anyway, so the cylinder block is quite securely bolted to the angle plate, and I've put a little chopped bit of wood under here to stop any vibration or whatever. So that's the setup for mounting it. So I think we're ready to do some machining. Alright, I think that can be all the clearance I need. So let's pull the setup down and do a clean up and a trial fit. From looking at pictures of the way the dipper works with in the factory setup, the pickup point is pretty much under the centre of the crankshaft. So that's what I'm going to aim for. So pickup point to be about 2 centimetres away from that. And the other dimension I care about is how much below, what's the stick out below that, and I think that's going to be about 3 centimetres, something like that. Well, I'll make it to 3, and then I can shorten it if I think that's too long, because I've got to allow for the piece to be, the tab to be bent onto the bottom. Okay, so here's the dipper that I've made. As you can see, it's a pretty good fit on the outside of the bearing cap, which is where it's going to go, obviously. I don't have any way of knowing how big to make these tabs on the bottom for scooping oil, but I suspect they'll be big enough. Looking at the pictures I could see of the original factory items, it's hard to gauge the size, but I don't think they were huge, because really what this has to do is splash oil up onto the crankshaft, which will flick it up there. It doesn't matter, I mean, it doesn't really have to sort of lift it from there all the way up there. Anyway, that's what I've done. We'll see how it works out. Okay, so let's put the crankshaft back in, and then we'll be able to test whether or not my dipper clears everything in a full rotation of the crankshaft. Alright, so let's see if it clears everywhere. Yeah, unfortunately my hand's just going to get in the way while I do the rotation. Anyway, so it's missing there where I relieved the material out of that part of the case. That's good. Certainly gets fairly close there, but there is a couple of 3mm clearance probably, and about 5mm there. So you can see it clears all ways round, which is rather encouraging. So something I have to decide is how much oil to put in the crankcase, and I'm thinking about I'll have about 3 centimetres or so of depth in the bottom there, and just running that as a check against the other half of the crankcase. You can see that 3 centimetres will be about level with the top of that existing hole, so I think that'll work out alright. And you can see the dipper is coming well down within that, so I don't think there's going to be any trouble spraying oil or picking oil up. Anyway, I won't know until I try, I suppose. Okay, well that's finished the changes needed to the lubrication system to the two parts of the crankcase, and I was starting to think about buttoning it back up, and then I was looking at this lot and thinking, well, the diameter of this output shaft here is 7/8 of an inch, which is a bit non-standard, and it's got these two Woodruff key pockets, so it might well be that I have to change pulleys to get the speed right and so on, so it'd be a lot easier if that was a standard size and whatever. So I'm thinking I'll turn this down to 3/4 of an inch and put a standard keyway in it, which would also create a shoulder for the pulley to press up against. But I try and keep these videos to half an hour, and I'm already over that, so I'm going to stop here, and hopefully you'll join me on the next one when I get all this lot back together. Cheers.